Hey, good evening, fifth graders. Tonight we're going to be working a little more with some fractions. We're going to be adding and subtracting mixed numbers. We're also going to be looking at a clock and how to do some fractions with the clock. That part's very easy. Please watch and press pause as we're going through this so you can learn as I am teaching this. All right, let's take a look at this first problem here. We're going to be adding, okay? One nice thing when we're adding fractions is we don't have to kind of look at the left side. We don't have to borrow. It's simply adding. So the only thing we have to do is we have to find a common denominator. So I'm taking a look here. I have an 8 and I have a 4. They both go into 8. Some of you are going 8 times 4 and you're getting all the way to the number 32, and then you have to reduce it all the way down. Let's keep it easy. If we don't have to change both fractions, let's just change one of them. So I'm going to change 1/4 into 8. Going times 2 gives me 2/8. So I'm going to rewrite this problem here. So I have 7/8 plus 2 and 2/8. Go ahead and add these up. I don't have a big number here. 2, so I have a big 2. 7 plus 2 is 9/8. Now we're not going to leave it as a mixed number improper fraction combo mix. So we're going to have to take a look here. How many 8s go into 9? 1. And then this, so 9/8 is also written as 1 1/8. And we have to add this 2 to it, so we have 3 and 1/8 as an answer. Let's look at another one here. Now we're subtracting. Let's go through all 3 steps of subtraction. First of all, is the number on the left larger than the number on the right? 3 and 5/8 is larger than 1 3/4. So that part is correct. Do they have the same denominator? They don't have the same denominator, so we have to change it. We have an 8 and a 4 again. So just like the last problem, we know 3/4. We know 4 can go into 8. Going times 2 gives me 6/8. I'm going to rewrite the problem. 3 and 5/8 minus 1 and 6/8. Now the third thing that we have to check is the numerator on the left larger than the numerator on the right. Sure enough, it's not. So that means we have to borrow. So we're going to cross off this 3 and make it a 2. We're going to be putting one of these whole numbers into the 5 here. Remember, each one of these is worth 8/8 right now because that's what my denominator is. So technically, we're adding 8 plus 5 to get a 13/8 minus 1 and 6/8. Subtract this across now. 2 minus 1 is 1. 13 minus 6 gives me 7/8. 1 and 7/8. Here we're adding up 3 different fractions, okay? It's pretty simple. All we have to do is follow one rule, common denominator. So let's take a look here. We got a 4, we have a 2, and we have a 4. They all go into the number 4. So I'm going to be changing half into a fraction with a 4 in it. Going times 2 gives me 2/4. I'm going to rewrite my problem here. 2 and 1/4 plus 2 and 2/4 plus 1 and 1/4. Go and add these across. I got a 2, and a 1, which gives me a 5. 1 plus 2 is 3, plus 1 is 4. 4/4. I'm not going to leave my fraction like that, but what I do know is 4/4 equals 1, and I've got a 5 here, so my answer is 6. I'm adding up some more fractions. I have an 8, I have a 16, and I have a 4. I know 8 can go into 16, I know 4 can go into 16, so I don't have to come up with this huge number because I know 16 can go into 16, but I do have to change 5/8 into 16. I also have to change 3/4 into a fraction with a 16. I'm going times 2 gives me 10. I'm going to go times 4 gives me a 12. I'm going to rewrite my problem now. I have 1 and 5/8 is 10/16 now, plus 1 and 1/16. I can keep that one the same. 3/4 change into 12/16, so I have 3 and 12/16. Right, kids? Now I can add these up. I'm going to change colors again. Go to green. 1, 2. So we have a 5. Now I'm going to add up this 10 plus 11, 10 plus 1 is 11, plus 12, so 11 plus 12 gives me 23 over 16. Remember, we're not going to be leaving the problem as a mixed number, as an improper fraction. So I'm going to change 23 sixteenths into, how many sixteenths go on 23? 1. What's left over? 7 sixteenths. And then I have to go and add my whole number to that. So that equals 6 and 7 sixteenths. Perfect. Here we're subtracting and we're adding. When we're doing this, we're going to read it from left to right, so we're going to subtract first. This first part's pretty easy. 6.5 minus 4 would give me 2.5 plus 2 and 1/4. 2 and the 4, when we're adding fractions, we have to find a common denominator, so we know half into 4, we're going times 2 gives me 2/4. So I have 2 and 2/4 plus 2 and 1/4. 2 plus 2 is 4. 2 plus 1 is 3. 4 is my denominator. We're adding, then we're subtracting. First of all, we're going to add. The first part of this is very easy. We're going to go ahead and get 6 and 3/8, right? Then we're going to subtract that from 1 and 3/4. We have to figure this problem out before we can do this part, okay? So we're subtracting. First of all, is the number on the left larger than the one on the right? It sure is. 6 is bigger than 1. Now we have to find a common denominator. We're going to change 3/4 into an 8 times 2. Times 2 gives me 6/8. I'm going to rewrite this problem. 6 and 3/8 minus 1 and 6/8. Now I have common denominators. I have to check, is my numerator on the left larger than the one on the right? It is not. I have to borrow. Taking away this 6, making this a 5. 8 is my denominator, so that means I'm adding an 8 to the 3. So I have 11 over 8 minus 1 and 6/8. I'm going to go ahead and subtract this. 5 minus 1 is 4. 11 minus 6 is 5/8. I'm not done with the problem, though, because I have to add this 5/8 plus 1.5. 4 and 5/8 plus 1.5. Once again here, I have to find common denominators. 8 and 2, they both go into 8, so I'm going to change half into 8. You see why scratch paper is important, kids. Make sure you are asking me for scratch paper in class tomorrow. I'm rewriting my problem. 4 and 5/8 plus 1 and 4/8 equals 4 plus 1 is 5. 5 plus 4 is 9. 8. I can't leave it because my numerator is larger than my denominator. So 9/8, we said earlier, is 1 and 1/8. I'm going to add it to the 5, so I have 6 and 1/8 as an answer. Okay. Last problem here, you're going to be dealing with a little bit with the clock tomorrow, okay? And as the technology age continues to grow, we're starting to see less of these clocks and more digital clocks, which is horrible to see. But things to keep in mind, okay? If I'm dealing with the clock, imagine it as a circle. That's half. If we have it in force, okay? From 12 to 3, this is 15 minutes, 15 minutes, 15 minutes, 15 minutes. So obviously half would be 30 minutes, okay? So that's a 30 and a 30. 1 whole, so this entire thing, this entire clock would be 60. Now, if they were to ask you tomorrow what 1/12 of 60 would be, you're just writing 60 as the whole. Times 5 would give you 5/60. If they ask you what time would be 5/12 of an hour, well, that's easy. Put it out as 60 again. You're going times 5. Times 5 would give you 25 minutes. Okay? If they ask you what is 1/4 of an hour, well, 1/4 would be just one little section, right? Which would be 15 minutes. If they ask you what 3/4 is, well, then you're going to have to take 3 of these parts, 1, 2, 3, which would give you 45 minutes. Okay? It's a very easy skill, But if you're not used to seeing these clocks, it gets a little tougher. And I've noticed this over the years. It's getting tougher and tougher for kids to do clock problems because you're not used to telling time with the clock. You're used to pulling out a cell phone or looking on your iPad and noticing what time it is. This is how I learned how to use a clock, okay? Take a look here. So this 9 right here would be 45 minutes past the hour would be the 9. Just keep in mind every single increment is in 5s as well. Okay? Since there's 12 of them, each one is 5, because 12 times 5 is 60. Hopefully that helped a little bit. I did some adding and subtracting of mixed numbers. Keep in mind when you're adding mixed numbers, all you have to do is find a common denominator. When you're subtracting, you're making sure the one on the left is larger than the one on the right, making sure you have common denominators. And lastly, is that numerator on the left larger than the one on the right? Hopefully this helped. I look forward to working with you in class tomorrow.